So this design question asked in 2017. So consider the following statements regarding golden ratio for positive integers. Okay. So the three statements are given. It is the ratio of difference of the two numbers and the smaller number. It is the ratio of sum of the two numbers and the smaller number. It is the ratio of the sum of the two numbers and the larger number. So we need to choose the correct answer from here. Okay. So see here, according to the definition of the golden ratio, okay, so golden ratio is defined like this. First I will write mathematically, then I will explain what exactly the meaning. For example, if I take the two positive number A and B which are greater than 0 and A is greater than B, okay, these numbers are in such a way that the greater number divided by smaller number ratio will equal to the sum of the two numbers A plus B divided by the greater number. Okay, so it will come approximately, this value generally come approximately 1.6. So this is defined as the golden ratio. So what is the definition of the golden ratio? It is equal, the ratio of any two positive numbers is equal to the sum of the numbers divided by the larger of those two numbers, okay, and that too equal to the 1.6. So what is this golden ratio? Sometimes it is called as a golden mean, or sometimes it is also called as the golden section, and so many other names also there for this one. Okay, so this golden ratio is comes when you are designing something. Okay, first time Greeks coined this one, and mathematicians also using. So whenever you design something, then if it is following the golden ratio, then it will become automatically aesthetically pleasing. That means for visual purpose it will be pleasing. Okay, what is the meaning of that? For example, if you are designing something rectangular, let's say rectangular golden ratio. So if I take the square, then what happened? It is not that much pleasing if you are drawing some diagram on this. So instead I will take in the golden ratio in such a way that, for example, here width is A and height is B. Okay, so here what is happening? B equal to 1.6 times of A. If I choose like that, then it is aesthetically and pleasing. Okay, that is the meaning of that. And what are the other natural example for this? For example, the spiral formation of the tree leaves, and even if you look at the the outer shell of the snail, even it will be something like that. It is a spiral, it would be spiral like that. Okay, this is also based on the golden ratio. Okay, how it formed we have seen in the lectures. Okay, so it will be used in mainly for the design purpose, and even arts, even in the mathematics. So, and one more thing here I would like to mention is, see, many times they may ask the golden hour. There is one more term, golden hour. So don't confuse the golden hour with the golden ratio. Golden ratio is related to the design, and that too for the more pleasing design, and the golden hour is related to the safety. See, what is the golden hour? For example, whenever whenever accident happen, or whenever someone met with an accident, then the first 1 hour is very much important. Okay, if they are able to get the proper medical aid within the first hour, then the chances of survival is very, very high. And after the 1 hour, the chances of survival drastically reduces, almost 60 to 70 or sometimes 80% the chances of survival reduces. That is why the golden hour is very much important. That means as soon as you met with an accident, then they should be provided with not you, I mean, as soon as someone met with an accident, then they should be provided with a medical aid. Okay, that is why Supreme Court also recently came up with the guidelines. The people who ever wanted to help the people who met with an accident, generally previously they are very much apprehensive about the police cases. Now they can readily help them, so that there won't be any harassment from the police. Okay. And here one more thing I will I will tell one more example here. What is that? The golden ratio closely follows the Fibonacci series. What is that? For example, 1 0 1, and if I add this, you will get the third number, that is 1. If you add last two, then you will get the next number, that is a 2. And if you add these two, then you will get the next number, like that. This is a Fibonacci series. Okay, so if I take any two numbers, for example these two, so according to this golden ratio, okay, 8 by 5, how much? It is approximately 1.6. okay, this is 1.6, and that should be equal to 8 plus 5 divided by 8, that means 13 divided by 8. So how much it is? It is also approximately 1.6 something. So both are matching here. Okay, so this closely follows that. So now what is the option? If you see the third statement, it is the ratio of the sum of the two numbers and the large number. So option is only 3. Okay, so option is B here. The next question, a clutch has to transmit 200 Newton meter of torque. Assuming uniform pressure theory and the ratio of outer to inner radii is 2.5, what are the radii for a uniform pressure of 2 megapascal with the quotient of friction of the linear material being 0.4? Okay, so here see, even for the mechanical stream also, this question is not so easy to solve in the examination. Okay, so what's about other branches here, like electrical and ECE, some other branches? How? See, if you see these type of questions, don't be scared. First of all, you use your intelligence, like you look at the options and you see whether you can directly get the answer or not, and if you are unable to get, then you leave it. Okay, so what is the question? Torque is given in the question, and then pressure is given, mu is given, mu is the coefficient of friction, and they also mentioned that what is the condition that we need to choose here, that is a uniform pressure condition we need to choose for the clutch. Okay, so what we need to find out? We need to find out the outer diameter and then inner diameter, that means capital R and small r. And what is the relation between capital R and small r? That is 2.5, that is given here in the question. So if you look at the options, which option is giving 2.5? This is not giving, this is not giving, and here it is becoming how much? The 4, and here only you are getting the 2.5. Only this value is giving 2.5. So what is the option here? Option is answer is option B here. Okay, so this is very, very easy question. So I think many of you might have scared in the examination. Okay, so see, it is not a mechanical paper. This is the general studies paper. Okay, so if he is giving very difficult question, means somewhere he will give some hint. Okay, that is why you need to choose here. But how to do this in a conventional manner? Okay, you need to learn the proper procedure also. So here, what is mentioned here? Uniform pressure. For example, how is the clutch? So clutch will be like this. Clutch will be like this. It is like a disc. Clutch will be like this. It is like a disc. Okay, so this is a clutch, and this is the shaft that is coming from the engine. Okay, it is rotating. This clutch will come and engage and disengage from the shaft, engine shaft. Okay, so here this is the disc, this is the disc. Okay, so this is the capital R and this is the small r. And what is the assumption that we need to choose here? That is the uniform pressure theory. Uniform pressure, what is the meaning of that? So whenever the clutch comes and engages with the engine shaft, that means there will be a pressure, the force applied on this, and because of that force there is a pressure between this clutch plate, okay, this clutch surface, and then a shaft. Okay, so the pressure between these two is uniform. Uniform means same throughout the clutch. That is one theory. And what is the other theory? That is uniform wear theory. Wear, uniform wear, W-E-R, wear. Okay, what is the meaning of that? See, this is applicable only for the new vehicle. Okay, new clutch. But what happens after some time when you use the clutch, then some of the portions will lose their grip, and there will be some wearing and tearing happening on the clutch. Okay, that means only the wear part is becoming constant after some time. Okay, in that case, what is the relation that we deduce? The pressure into the radius from the center is always constant. That is the relation we deduced in that case. Okay, we will make use of this. So here, we already derived the equation. So for the torque, here pressure is given. If pressure is not given, force is given, then we know how to use the formula, but here pressure is given. So what is the formula? Mu pi p divided by 12 into capital D cube minus small d cube, and here this is nothing but capital D by small d. Okay, and if you substitute the value, then what happened here? So if I substitute capital D equal to 2.5 into small d, then d cube into 2.5 whole cube minus 1 equal to torque is how much? 200 Newton meter. 12 divided by mu is how much? 0.4 into pi into 2 into 10 power 6, because it is a megapascal. And see here, even though you can able to do this calculation part, then how to find out the cube root? Okay, so cube root, finding cube root is not so easy. So in that case, in the examination there is no other way, so directly I can write this is something like a 40 mm. That is why examiner, I think, given very easy options. Okay, by looking at the options you can do this. And capital D is how much? 100 mm. So half of these are like 20 and 50 mm. Okay, this is how we need to do. And what is the formula? What is the torque formula in case of uniform wear theory? Okay, what is the torque formula in the uniform wear theory? That is T equal to pi mu p divided by a small d into capital D square minus a small d square. Okay, this is how I need to find out. Okay, hopefully, see, if problems are involved in higher power, then you see whether it is easily calculation whether easily go or not. If it is not going, then there is no other way. You go for the options. First of all, you go for the options. Okay. Next question is, consider the following statements regarding the V-belt drive. The groove angle of the sleeve is less than the belt section angle. The efficiency of the V-belt drive is higher than that of the flat belt drive. The groove angle is so made that the belt wedged in the groove. So we need to choose the correct options from this. So here there are two types of belts generally, flat belts and V belts, and there are other types of belts also. So see, in case of a flat belt, what happens? The flat belt more tend to the slipping. Okay, but whereas in this case V belt, this is a V belt, so this is the belt one. Okay, if this is the, for example, belt is like this, and I cut at one section, and then I'm looking at the belt cross section. This is the belt cross section, and see the V shape, because that is why it is called as the V belt. And this is the angle, and this is called as the belt angle. Okay, this is the belt angle, and this is the sleeve, and on this sleeve generally we will make a groove here so that it will come and fit here. So what is happening? For example, this is the groove I am making here, and if the belt is coming here and sitting like this, belt is coming and sitting like here, then what is happening? There is a gap between these two, then it will slip. There is no difference between this belt and the flat belt. So instead of that, what I make is I will make the groove like this. I will make the groove like this. That means the angle of the groove, angle means what is the angle of the groove? This is the angle. Okay, this is the like a alpha, and this is the beta. So alpha is the angle of the groove. The angle of the groove is less than the angle of the here. What is happening? The angle of the groove is less than the angle of the belt here. Okay, so in that case only what is happening, it is a tightening the belt here, it is a tightening this belt. So what is the meaning of that? When it is a tightening, then it is trying to form some wedge here. Okay, so that means wedge action is happening. How, when will the wedge action happen? Only when the angle of the groove of the sleeve is less than the angle of the belt. Okay, you remember this. Okay, that means here alpha value should be less than the beta value. So what is happening in the wedge action? It is trying to squeeze it. When it is trying to squeeze it, when the pulley is rotating, there is a more friction between there is a more friction between a belt and this groove. Okay, that is why no slip is happening. So you may think like, oh, when it is very tight, belt is no slip is happening very tight, then you may think that it is producing more power. Okay, but in reality what happens, we will see that. What happens, for example, if you take the any efficiency of the belt, any belt, then it depends on the friction between the belt and the pulley, creep and slip. So what is the friction between a belt and the pulley? If more and more, if it is very tightly fixed between the groove, if the belt is bent very tightly between the groove, then what happening, there is a more friction between a groove and the belt, and whatever power you are giving to run the pulley or transmit the power, what is happening, some of the power will be used to overcome the friction between these two. Okay, that means the efficiency is decreasing. So what is the meaning of that? Appreciable amount of friction should be there, but if there is more friction between the belt and the pulley, then what happens, there is a decrease in the power here. And the next one is the creep. What is the creep? Slip means when belt is, this is a pulley and the belt is going like this. When bolt is going, if it is a slipping, then it is a slip. Okay, and what is the creep here? So creep is different from the material science creep, whichever we studied for the material. Creep is relative motion of the belt as it passes on the pulley. So what is the meaning of that? For example, here this is a one pulley and this is another pulley. Okay, so this is the belt. This is the belt. So when the belt is going like this, when the pulley is rotating like this, then what happens? This is the tight side. Okay, it is a slack side. Tight means because of this belt, it is also being rotated in the clockwise direction, so it is very tight here. So when you are pulling the belt very tightly, then what happen, it will stretches little bit, it will stretches. Okay, then as soon as the belt enter this point, particular point, then what is happening, the pulling effect is over. So whenever the pulling effect is over on the belt, then whatever the structure portion is there, it will try to contract. Okay, so here when your belt reaches this portion, then it automatically contract, the belt will contract. Okay, that means the velocity, there is a change in the velocity within the belt. Okay, when it is contracting, see, this is the belt, it is a, see, point is, this is the point and it's supposed to reach here when it is coming here, but because of the contraction it will reach here only. That means there is a decrease in the velocity. Okay, so there is a relative change in the relative motion of the belt with respect to the pulley here. Okay, because of this. So because of this also what happens, the efficiency decreases. So here in case of the V belt, the creep also more. Why? It is tightly held because of the wedge action. So because of that also the efficiency decreases. So for these reasons, what is happening, contrary to the general belief, efficiency of the V belt less than the flat belt. Okay, so these are the two things we need to remember. But the V belts are, the slip in the V belt is very, very less. That is why we use, V belts in the so many automobiles, and whenever there is a electric motor as a primary mover, then there also we will use this. Okay, V belt. So even in the vertical transmission also, vertical shaft transmission also, vertical position also you can keep the V belt, but whereas the flat belt it is very difficult because it will slip off. Okay, so here what are the options? For example, first one, the groove angle of the sleeve is less than the belt section of the angle. Yes, that is the correct. Generally, if you look at the design, generally the V belt angle would be taken as a 40 degrees. Okay, and where that this is a beta, and whereas the groove angle alpha is something like 34 degrees to 38 degrees. Generally, this is how they will be chosen. Okay. And then what is the next statement? The efficiency of V belt drive is higher than that of the flat belt. It is false. Okay, so 2 is wrong. So 2 is everywhere except option C. You can choose directly C. But anyway, we will see in the third statement also. The groove angle is so made that the belt wedged in the groove. Yes. Why the angle of the groove is less than that of the angle of the belt? Because it is trying to squeeze it. That means it will form a wedge. Wedge means this is the wedge here. It is a tightly pressing against the groove. Okay, so option is C, that is a 1 and C.